Hello, my name is Kelly Argueta,
And my name is Monserrat Castillo.
and this is our final project for data mining. We are using two data sets for this project. We are using the Charles Book Club and the obstructive sleep apnea. And the CVC data set focuses on predicting book purchases by using classification models. And the obstructive sleep apnea data set is used to cluster patients based on shared characteristics. Our goal is to find the best classification model for the CVC dataset and identify the best clustering algorithm for the obstructive sleep apnea dataset. So, for the first part, this is our explanatory data analysis. The CVC 3200 is for training and validation, and the CVC 800 is for testing the dataset. Each row represents a client, and each column is a feature, for example, gender or purchase behavior.
In the exploratory data analysis, we checked out the correlation with the feature of the Florence. We saw it's imbalanced, so that means we need to work in the data. So we decide we're gonna check it out missing values and handle them, escalated the data, separating feature and target, balancing classes, and removing outliers.
We're using 4 different models to compare which perform better. We are using support vector machine, gradient boosting, random forest, and logistic regression. Based on the results, we can tell that the random forest is the one that best perform compared with the other models.
Also, we compared the random forest doing another kind of score classification like precision, accuracy, and F1 score. It shows it performs better than the other ones. And also in this graph, we can see this confusion matrix for the random forest where the top left, it shows like people buy the book and confirm it is true. We bought the book, and for example, the one in the right will be like the prediction of people didn't buy the book. For the code, we use the simple inputter for replace missing values with the mean of the column. Also, we use the standard scalar. We scalate numerical data to have a mean of 0 and a standard deviation of 1 for C-score normalization. We create also a feature called monetary bin. We divide the column of M in 5 different mean levels from 0 to 4 for later be able to see which group of people buy more the Florence book. Also, we split the features in X and Y of the training data. And also we use the techniques mode for balance the dataset using genetic samples for fulfill the minority classes. Also, we remove outliers with the zeta score, so only will retain the absolute zeta score if it's less than or equal to 3. And just we split the data into training and validation set.
For part 2, we're working with the OSA dataset. And some features that this dataset has is age, and glucose, BMI, calculated CO2, among others. We also applied UMAP to reduce dimensionality, and we also explored clustering methods to group patients with shared traits. We use 4 different methods as well for this dataset. And based on the results, the K-means is the one that best performs with clear cluster separations, comparing with the other 3 models.
How we can see in these graphs, we can see the K-means clustering can differentiate the data and split it in 3 clusters when the DBS scan is not payable. And if we see the score of the select, for example, we can see it's very low for DBS scan and much higher for Cummins. About the code, we use the UMAP model for dimensionality reduction. We indicate 2 components, so we will reduce our data to 2 dimensions. And then later, for make the clustering with the Cummins, we indicate 3 clusters with a random set of 42. And also, we make it fit the 2-dimensional reduced data into the Keyman model.
So in conclusion, we say that the random forest is the best classification performance in predicting book purchases, and the K-means was the most effective clustering algorithm for grouping the OSA patients. Some improvements for the future that we can say is pre-processing steps, for example, future scaling and dimensionality reduction, and also addressing imbalances and noise significantly to enhance the model's outcomes, enhance interpretability of K-means clusters, as well as investigate more advanced sampling techniques for the CBC dataset. Here are some references. Thank you.